Thanks to Brilliant for supporting this episode of SciShow. Go to brilliant.org/SciShow to learn how you can take your STEM skills to the next level. In July 1983, a weather station in Antarctica recorded the lowest air temperature ever measured on Earth. It was about -89 degrees Celsius, which is colder than the average temperature on Mars. But 25 years later, scientists analyzing satellite data found small pockets high up on the East Antarctic Plateau where temperatures routinely drop about 5 degrees lower, making them the coldest spots we know of on Earth. But these pockets aren't just for record books. They're also helping us understand how cold it's possible to get on the surface of our planet, and what conditions it takes to get that cold. These record-breaking temperatures happen during long polar nights within little hollows in the ice sheet, more than 3.5 kilometers above sea level. On still nights when the sky is clear, the air near the surface of the snow cools down as heat radiates into space, and it becomes denser than the slightly warmer air surrounding it. As a result, it starts sliding downhill along the ice sheet and sinks into these hollows. If the wind is light enough, the super cold air gets trapped down there, and it acts kind of like an ice pack, which brings down the temperature of the surface even more. When that happens, the air temperature drops down to those record lows until weather stirs things up again. But the lack of wind isn't the only thing you need to get those temperatures. It also has to be extremely dry because water vapor can keep heat from escaping. See, heat might feel like this abstract thing, but it's just waves of infrared radiation. So when heat escapes our planet, infrared waves are radiating from the ground and into space. When the temperature drops, there's less heat coming from the surface, so the waves carrying that heat away lose energy and stretch out. And those longer waves are more easily absorbed by water vapor in the air. So if there's any moisture in the air, a lot of that radiation won't escape into space, it'll be absorbed by the water and sent back to the ground to warm things up. In fact, to get below about -90 degrees, you need less than a millimeters worth of water in the entire atmosphere stretching from the ground all the way into space. In other words, if you wrung out all the water from that air, it wouldn't even reach the 1 millimeter line on a rain gauge. Those are some strict requirements. But for the researchers studying this, the really surprising thing wasn't just that the temperature got so low in these pockets. It was that, over time, it dropped to nearly the same low temperature over and over again. Like, across 14 years and hundreds of kilometers of the plateau, the lows at the coldest sites hovered right around -94 degrees, just above the all-time low of -98. So scientists wondered if the temperature was hitting some kind of threshold, if it was reaching the coldest temperature possible on the surface of our planet. And that does seem to be what's happening. See, even on still, dry nights, the heat doesn't radiate away forever. Instead, a lot of that infrared radiation gets trapped by carbon dioxide, because while CO2 always absorbs some heat, it's especially good at absorbing these longer wavelengths. So at that point, the air itself is trapping heat and sending it back towards the surface. The atmosphere essentially acts like a blanket, and heat can only escape from the surface really slowly. Eventually, around -98 degrees Celsius, the temperature is dropping less than half a degree a day, too slowly to really change before the weather shifts and winds stir things up. In theory, if air could sit still for days or weeks on end, the temperature could drop lower, but on a planet with so much weather, -98 degrees is essentially as cold as it gets. Which, hey, is fine by me. It takes some creative thinking to find and demystify something like the coldest place on Earth. And if you're interested in learning to think like a scientist, or better understand the science behind discoveries like this, you might be interested in the courses offered by Brilliant. Brilliant offers dozens of courses in science, engineering, and math, and they're hands-on with interactive quizzes and guided problems with explanations, all designed by educators at leading universities like MIT, Caltech, and Duke. You can save 20% on an annual premium subscription if you're one of the first 200 people to sign up at brilliant.org/SciShow.